not going to freeze up today. All right. So, a couple of things. So technically, this is the last full day of the week, even though it's only a Tuesday. I know. So if you have class tomorrow, we here at West will have normal classes. If we were here live and in person 100%, we would have normal classes until 11 o'clock. And then at 11 o'clock, you would be released, and your day would be done. And so we were instructed that we are supposed to follow that times tomorrow. Okay, so we will have 3 classes tomorrow in the morning, starting at 8, 9, and 10. I have the 8 o'clock. Mr. Roth has the 9 o'clock and the 10 o'clock. Okay. So if you have class starting after 11 o'clock and you have off during one of those times and you have questions, come on in. Okay. It's going to be basically just be a Q&A kind of a deal. So if you have questions, we can get those answered because we are going to open tomorrow at 11. It's pre-scheduled to open tomorrow at 11, the section 4.1 summative. So basically what we do is we take chapter 4 and we break it up into each section. And we take a summative then on each section kind of a deal because chapter 4 is trig. Okay, and so we'll be in chapter 4 for probably the rest of the semester, if not a little longer. Okay, but we're going to take it and we're going to break it up into different parts and things of that nature. So we have that. So that test will open tomorrow at 11 a.m. and it will stay open until 11:59 p.m. on November 2nd. Okay. So you've got time to do it. It'll probably end up being somewhere in the neighborhood of 11 or 12 questions, and you'll have 90 minutes to do it, kind of a deal. Okay? So we got that going, which is nice. Okay? And then so Thursday, we will not have anything planned for Thursday other than you doing the test sometime between tomorrow at 11 a.m. and Monday at 11:59 p.m. Same with Friday. We'll have nothing planned except for you to finish that summative. Okay? Any questions on that? Those that have their cameras on, we good? Morning, Estella. Just so you know, I am still, for my grading students, I am still waiting on some people to take, if you go back, I'm still waiting on people to take the Chapter 3 test. And I don't think, nope, Chapter P, everybody's done. But yeah, I'm still waiting on a couple of people to take the Chapter P, or the Chapter 3 test, excuse me. A couple of homeworks out there missing, and a lot of people are still missing the formative that was due over the weekend. So if you are one of those people that are missing some things, just remember that technically tomorrow at 11 o'clock is the end of the first quarter. So grades are going to be locked in here pretty soon. I'm tentatively looking at Monday-ish to lock in grades, and Monday the 2nd, Monday November 2nd to lock in grades, and that will be your quarter grade. So that comes into play for quarter grades that go home to your parents that get reported out for different things like winter activities, concerts, etc. Winter athletics are all based upon quarter grades. So there's a few of you out there that need to do a lot of things here in the next few days. Okay. So with that being said, let's get at it. Last week you should have watched a video in regards to the 3 different kinds of speeds. We call this the speed chart. Okay. So the first kind of speed is rotational speed. How many times you're going around a circular object in a certain amount of time. Sneeze. Ooh, excuse me. Second one is angular speed. Angular speed is the amount of degrees or radians that you go around on that object on a certain amount of time. Okay? And then the last one is linear speed. That's the one that you are most familiar with, especially if you are a driver. Linear speed would be distance divided by time. Miles per hour is a common linear speed. Okay, that's why all drivers need to be familiar with linear speed, because sometimes if you're going too fast, then your linear speed gets you in trouble. Not saying that that's ever happened to me before, but it has happened once. I finally got my first ticket, my first speeding ticket, last spring after 30 some years of driving. So, okay. And then we can also find distance based off of that. Okay. So let's jump into one. Okay. A truck wheel with a diameter of 36 inches. Remember, 2 slashes is inches, 1 slash is feet. Okay. Rotates at 630 RPMs, revolutions per minute. RPMs is a rotational speed. Okay. Find the speed of the truck in miles per hour, linear speed. Well, we start with the speed that we have is 630 revolutions per minute. Now, the nice thing about speed is it's going to tell you what you need to have your answer in. You want your answer in miles per hour. So if we use the factor label method that we taught you a couple weeks ago, or that you've learned in many, many science classes, you're not going to stop until you've got miles as your label on the top and hours as your label on the bottom. And how you get there doesn't matter, as long as your labels are always canceling out. So the first one that I would multiply by is there are 60 minutes in 1 hour. And so now my minutes have canceled each other out. And so now my label is revolutions per hour. So I've got this part accomplished. Now I just have to transfer revolutions into miles. Okay? So if I'm going revolutions, well, 1 revolution is 2 pi radians. So now I'm in radians per hour. I'm in my angular speed. Okay? Now I can multiply by the fact that 1 radian is equal to 18 inches. Because my diameter here was 36 inches, that means that my radius is 18 inches. And now I'm in inches per hour. So I need to convert inches into miles. Well, there are 12 inches in 1 foot. Well, I'm going to run out of space, I think. I got to go a little, I got to move some stuff over here. Hold on. There we go. And then that one goes up there. That one's going to come over here. And that one's going to go there. This one's going to come over here. And that one's going to come over there. And this one's going to come over here. And now I've got plenty. Whoa, hey, whoa, a little too far there. Now I got plenty of space. Okay. So now I am in feet per hour, and in 1 mile, there are 5,280 feet. So the only label that I should have left on top is miles. Yep, the only label I should have left on the bottom is hours. Yep, perfect. Okay. So on top, we've got 630 times 60 times 2 pi times 18. On the bottom, we have 12 times 5,280. Okay. So, let's see. 12 goes into 60 5 times. 5 goes into 5,280. 5,280 divided by 5. That would be 1,056 times. 2 goes into 1,056. 528 times. 7, 8, yep, so that one's divisible by 6 is 88. If I divide this one by 6, I get 8. Oops, if I divide by 6, I get 88. If I divide that one by 6, I get 3. 630, I don't think is divisible by 4. Oh, I know it's not. But it is divisible by 2 at 315. No, I gotta go with a different color here. Red, purple. I didn't go purple. 2 is 315, and 88 divided by 2 is 44. I don't think that there are any more. Okay. So on top, I get all of that is 315 times 3 is 945 pi divided by 44 would be my exact answer. Or approximately 67.473 miles per hour. The black one would be the exact form. The maroon one is rounded to 3 decimal places. Questions, comments, concerns, clarifications? The 9 of you that have your cameras on, good, thumbs up. Thumbs to the side, we need a little bit of more practice on that. We're going to get some here in a little bit. Thumbs down, we got questions. Linzmeyer's all cray-cray with his crazy factoring of his fractions, so he didn't have to. Side note, we could have just straight up multiplied 630. I should even do that. 630 times 60 times 2 times 18, and we would have gotten wrong color. We would have gotten 1360800 pi, and then we would have done 12 times 5,280, and we would have gotten 63360 if we wouldn't have done any simplification first, and then we could have done that times pi divided by 63360 and gotten the exact same 67.473. Okay? So we could have done that if we were wanted rounded. We would have had to reduce that red fraction if we wanted it exact. Okay? A bike with a 28-inch diameter wheels is racing at a speed of 36 feet per second. How many revolutions per minute are the wheels making? This sounds like a great You try it, and then we go through it, kind of a deal problem. Go for it. So the one speed that I have is 32 feet per, or 36, excuse me, feet per second. I want to go into revs per minute. So that's a linear speed that I have. And so we need to make that then become a rotational speed. So let's first deal with seconds into minutes. So there are 60 seconds in 1 minute. Okay, I like that. The diameter of my bike was 28 inches, which means then that the radius of my bike is going to be in inches. So let's get feet out of there and inches into there. Okay. So now I'm sitting there, and then 14 inches is 1 radius, or radius of my circle. So now I'm in radians per minute, and then the last one that I would have to do would be that 2 pi radians is 1 revolution, and now I am in revolutions per minute. Love it. So we would have on top 36 times 60 times 12. On the bottom, we would have 14 times 2 times pi. There. So I would say here then that 14 goes in there 7 times, 12 goes in there 6 times, and 2 goes in there 3 times. So exactly, we would have 36. Oops, got to turn it on first. 36 times 60 times 3 would be 6,480 divided by 7 pi, and that would be in revolutions per minute, or RPMs, if you will. So then that is going to be divided by 7. It's going to be just 6,480 divided by 7. Approximately 294.664 RPMs. Again, black is exact, maroon is rounded. Okay. Thumbs up, we're good. Side, I need some more practice, and there's a couple of practice worksheets out there for you from yesterday. Down, we've got some questions on this one. I see 3, 4 thumbs up. Okay, there's some more thumbs up. Of the 7, 9, or 10 people that have their cameras on. All righty. Okay. Next one. During the spin cycle, my washing machine rotates at 1400 RPMs. If the drum has a 27 centimeter radius, at what speed is Grant's lost sock spinning in miles per hour? Okay. Go for it. Let's do this one. Find me the miles per hour that the washing machine is spinning at. So we know it's spinning at 1,400 revolutions per minute. We want it in miles per hour. So 60 minutes is 1 hour. Minutes gone. Now I'm in revolutions per hour. 1 revolution is 2 pi radians, and now I am in angular from rotational. Now I am in angular. 1 radius is, the drum has a 27 centimeter radius. Okay, so we're there. So I'm in centimeters per hour. I want to be in miles. So that means I got to find my conversion of centimeters to inches. 2 inches. There it is. Centimeters to inches. So centimeters is, so 1 centimeter is 0.394 inches, according to the Google. So now I am in inches per hour. Then inches now is, so 12 inches is 1 foot. 5,280 foot is 1 mile. Inches, foots leaves me with miles per hour. So on top, I've got, go right to it. So I've got on 1,400 times 60 times 2 pi times 27 times 0.394 equals that, and that's going to be divided by 12 and divided by 5,280. So that sock is spinning at approximately 88.614 miles per hour. Okay. Yes? Thumbs for the 10 that have lights on or cameras on? Thumbs? Love it. Extension question based off of that one. So, in a 15-minute spin cycle, so the drum of the washer is spinning for 15 minutes. How far did that sock travel in that 15-minute spin cycle? So it traveled at 88.614 miles per hour, and it traveled for 15 minutes. Well, 15 minutes is 1/4 of an hour. Oops, put that in a different color. 15 minutes is 1/4 of an hour. So my hours cancel each other out. So if I take that, and it should still be on your calculator yet, and I simply divide it by 4, that sock traveled approximately 22.154 miles spinning around in your washer. You would be amazed at how accurate that is and how far your clothes go just spinning around in a circle in your washer or spinning around horizontally in a circle in your washer. Okay? It's mind-boggling actually. It's kind of cool math if you do some rotational work with it. Okay? Try this one. Mrs. Hill is cruising on her new, I don't even know how to say that, Xme electric scooter at a maximum speed of 15.5 miles per hour around the mean streets of Wausau. At this speed, how many revolutions per minute are the 8.5-inch diameter wheels rotating? Love it. Per minute, revolution per minute. Miles per minute. Let's see. So what is my radius in inches? So we got to change over miles. Is at 5,280 feet. In inches, so we're in inches per minute. Okay, so that's my linear speed now is in inches per minute. I want revolutions, so now I can go with 4.25 inches is 1 radian. So I'm in angular speed now in radians per minute. And then I can finish it off with, then I can finish it off with 2 pi there. 2 pi radians is 1 revolution. And I'm in revolutions per minute. Love it. Okay. So we've got 15.5 times 5,280 times 12 on top. So that's 982080 on top. On the bottom, we've got 60 times 4.25 times 2. That's 510 pi. It's me. I should do that all in one. 982080 divided by 510 pi gets me, I get approximately 612.952. That would be RPMs. Yes, indeedly do. Right? Technically, the reduced fraction on this one, actually here, let me reduce it here this way. Technically, the reduced fraction would be that. Okay? If we wanted to be exact, that would be the reduced fraction. Actually, it could be even going even further, because I think it can be, I think we can divide both by 3 on top, but close enough. Okay? All right. So we're at the 45-minute mark-ish, and I'm fine with that. That's all I've got for rotational speeds. If you want to hang out here for Billy Goat, the Billy Goat problem, because I really love doing the Billy Goat problem. It's kind of fun. We can hang out and we can chat. But otherwise, Mr. Roth this morning let kids go if they wanted to go, or if they got another class going on at this point in time. So it's totally up to you. I have taken attendance already. Make sure I didn't miss anybody. Yep, didn't miss anybody. Okay, so if you want to hang out, great. If not, your test opens up tomorrow at 11 a.m. Make sure you get it done, kind of a deal. Okay? So totally up to you on your hangoutness. Okay? I am going to be doing the Billy Goat problem here, except I am going to break this one up because I want to move this. I want to move this over a little bit more. But I want to do something else. I want to set the current page. Shabam, there it is. Exactly what I wanted. And then this one. This. Shabam. All right, so that one gets deleted. And now we have Billy walking. All right. So Billy, a goat named Billy, is tethered to a post 10 meters from the corner of a 10-meter wide by 30-meter wide long barn, or by 30 meters long barn, as shown in the diagram. If the rope is 30 meters long, what is Billy's maximum possible distance traveled, okay, in one direction when he attempts to walk in a full circle if he keeps his rope fully extended? So his rope is always going to be extended. Okay? So what we need to do here is I am going to bring in a compass just to make it easier for us. Okay? So if Billy's here, and Billy, will it extend out? Maybe shrink Billy a little bit here to, oh, come back to me. There, we'll make Billy a little smaller. Okay, so Billy can walk all along here. Okay, with me? Okay. So that's what Billy can walk. But then when Billy gets to here, let me put in a line segment, and it's got to be purple, and it's going to be here, straight down, and here, straight up. Okay. when Billy gets to there, so there's my semicircle. Love it. Good times. But now, when Billy gets to here, now we got to change colors. Now Billy, oop, that should have been exact, but that's okay. We'll let it slide. Okay? So in purple, so that's half of a 30, what are we in, meters? Meter circle. So that circumference, so that would be 1/2 times 2 times pi times 30. 2 pi r is my circumference of a circle. So that would be 30 pi. Okay. Then in green up here, so this, oops, let me move this out the way. Okay. So this right here would be 20, because down here is 10, 30 meters long, it's 20, which means then that this radius up here would be 10. So we are at a quarter of a 10-meter circle. So that would be 1/4 times 2 times pi times 10. And that would be what? 5 pi? Okay. And he would wrap around. This should be the same. That should be right at the corner, kind of a deal. Okay. But down here now let's go down here to the bottom. Down here now, Billy's got a 20-meter rope yet that's still coming out. So let's go in the blue. There we go. So now we come out here. And Billy can walk that. And Billy can come to there. So that is a quarter of a 20-meter radius circle. So that is going to be 1/4 times 2 times pi times 20, which is 10 pi meters. But this out here is still 10 more meters. So now, whoa, tap the brakes. So now Billy can also walk to there. Okay. And so that then is another quarter of a 10-meter circle. And so that's going to be same as green. So that's going to be 5 pi meters there. So in all, so in all of the distance that Billy can travel, so purple is 30 meters, 30 pi meters, plus green was 5 pi meters, plus blue was 10, plus red was another 5 pi. So all told, 50 pi is what he can walk. We've got green, we've got purple, we've got blue, and we've got red. Yep. So all told, he can walk 50 pi meters. 50 pi is, so he can walk 157.080 meters. Good times for Billy the goat. Huh? That is all that I have for you. Okay? Thanks for playing along. If you have any questions, stick around in the chat. I will be more than happy to answer them for the remaining mod of class.